Good morning, everyone. I'm back with a follow-up to the video that we did last night. So I'm going to call this, I don't know, something Jeremy IT Labs Day 26 OSPF configuration lab. I went back and I watched how he solved the lab that we worked on last night, and I had some questions that I was kind of like verbalizing throughout that video. And I got some answers to them, and they're pretty clever. So I think I was closer than I thought. And so that makes me feel good because I am at least able to, navigate my way through some of this stuff, as uncomfortable as it kind of feels sometimes. So anyway, the first thing that I wanted to call out was that, there was I had a lot of discussion yesterday about how to enable OSPF. And the way that we did it was actually, we did it two ways, and they were probably redundant. So the first way, I'll just go to R1 as an example. Everything is still up here. The first way is to go into, obviously, router configuration mode, provide a process ID I was just doing one, and then from within this mode, use the network command to enable OSPF on interfaces that match the wildcard and the network that you use here. So in the case of router 1, we did 10.0.0.0 and 10.0, so 10.0.0.0 to encompass this subnet, which has a 13 in the third octet, and this subnet, which has a 12 in the third octet. So by doing 10.0.0.0 and giving it a wildcard mask of 0.0.255.255, everything is included. And therefore, OSPF is enabled on both of those interfaces. Now, one thing that Jeremy points out, which is worth mentioning, is that you can go both directions with this. You could just say, hey, I'm going to have OSPF on any interface ever on this router by making it as wide open as possible. And this is stuff we've seen before for like default routing and whatnot. So if you do 0.0.0.255.255.255.255, that's going to match any IP, any subnet that's connected to the router. OSPF will be enabled for. So that's like the widest open. And you can also do very specific ways. So for example, let's say we only wanted to enable OSPF on the G00 interface of router 1, and we wanted to be very specific about it. So we could just do, like we've seen with subnet masks in, again, /32 subnetting, we could do 10.0.12.1, like the most specific address, and then just do 255, 255, 255, 255. And that will enable it, and that is very specific. So I just wanted to point that out. There are multiple ways to enable this, very specific or less specific. And my instinct is that in the field, you would want to be more specific. Okay, so that was the first big thing. The next big thing, there were basically three items. The next one is, I was confused as to why, for example, there was no default route. Let's see, en show IP route. I was expecting to have a route learned via OSPF with an asterisk on it, this candidate default, like a default route. And I configured router 1 to originate that default route, like from the outside, but it did not propagate out to these, and I was confused as to why. And that is because we didn't quite get to the finish line. We actually need to create a route to propagate. And once a route is created, it should propagate out to the rest. So I'm going to go back into configuration for router 1, and I'm actually going to create that default route. And I think I need to get back to this mode to do so. All right, I'm going to say IP route, and actually maybe I do need to be in configuration mode. I think I do. Okay, so conf t IP route, good. All right, so now I'm going to create a default route, which is like, again, a very wide open route. So everything here, and this is just a regular subnet mask. In fact, I can confirm that by prefix mask. I thought it might say subnet. All right, and then we need to give it the next hop. And the next hop in this case is going to be the ISPR's router on its G000 interface. So that's going to be subnet 203.0.113.2. So 203.0.113.2. And that's the next hop router. All right, so that is done. The other thing before we check that the propagating or that the route's propagated out, I want to do show. So let me exit out of this. I could have done do there. I recognize that. Show IP protocols. All right, so now one thing that is interesting about this, okay, so first things first, the router ID is 1111, which is the loopback interface. And I learned that the router ID, there's like a series of questions you ask, what is the router ID going to become? And the first choice is like the lowest loopback interface ID. So that's why this router ID becomes 1111. And that's why when we look at like the neighbor tables and different things, they're all basically like using this loopback ID, which I thought was kind of confusing. But now it makes sense because I read about how the router ID gets chosen. One thing that doesn't make sense to me right now is the fact that this router 1 is not yet the O or the ASBR that advertises a route. So let me do let me try to do the default route originate thing again. So I'm going to do conf t, and I'm going to say router OSPF process ID 1. All right, question mark, default information, question mark, originate. All right, I actually did that last night, so I don't know why I would need to do it again, but let me now exit, and I want to show IP protocols. So outgoing update interface, router ID, number of areas in this router is 1, 1, and blah, blah, blah. I'm expecting it to tell me something that it is like an area border router. So I'm going to Google that real quick. How to set router as ASBR CCNA. To configure a router as an autonomous system boundary router, ASBR and OSPF, you need to enable redistribution of routes from another routing protocol like static route, blah, 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 into OSPF. This makes the router an ASBR because it's essentially injecting routes from outside the OSPF domain. You can also make a router an ASBR by using default information originate. Understanding OSBR, okay. Router 1, OSPF, default information originate. So I did that. I wonder too if I can ping router 1 from ISPR, or can I ping ISPR 1? So let's get onto here and let's say, because I might not have the IP address set up. So ping 203.0.113.2. I think that's going to fail. All right, so that's failing. So let's do I have G30 set up even with an IP address right now? Probably not. So show IP interface brief. So gigabit 30 is down. All right, so that I probably definitely need to fix that. So I'm going to do conf t interface gigabit 3/0, and this needs IP address 203.0.113.1. 255.255.255.252 is our /30. All right, and I'm going to say no shut. Now it's up. And I'm curious if I need to do the configuration on ISPR1. So let me try that real quick. CLI. It looks like its link is up. So if I say enable show IP interface brief, it's got an 000 and it's up with router 1. All right, so I think this might all be hooked up now correctly. So I'm going to try again to exit. What did I say? Ping. I tried to ping a second ago, I thought. Exit. Ping 203.0.113.2. Is that going to work? Yes. All right, so that's all hooked up. Now the question is, did router 1 propagate that default route out to everyone else? So does router 3 have it now? And it does. Sweet. All right, so that is great to see. We could tell by the asterisk that it is a default route, which you see here. And everything is going via 10.0.13.1 in the case, or from the perspective of router 3. So that means like, oh, it's like I need to go up to router 1 to get out to this other stuff, and anything else that's default. All right, so that's pretty good feeling. The default route propagated out. Now I'm curious, can ISPR ping PC1? So that's 192.168.4.1. Let's see, I'm just curious. Ping 192.168.4.1. And it can. That's awesome. All right, so drop one packet to do ARP, address resolution, and then the rest succeed. So pretty exciting. We can ping all the way from here. There's a dynamic routing protocol that's choosing the shortest path. All that configuration is up. Heads out to the switch, heads out to the PC. The PC says, okay, give me my reply, blah, blah, blah. Makes it all the way back. And in fact, let's check the simulation. So we're gonna simulate this ping again. And I wanna do that. All right, and now we're gonna go back. All right, and we can kind of like follow the little envelope down its path. And next, oh, there it goes. All right, so it went across and down. Nice. Move it along a little faster here. All right, then the PC is responding, and it's going to take a different path back, it looks like. There we go. So there's got to be a reason for that, and I'm sure it has to do with cost. Why it takes one path down and one path back. Well, for example, yeah, you would think with this square shape that it would just take the same path. But if it gets here, it has, oh, that's why. Well, then it just went down that way. So I still have to work on that, like what the algorithm is actually doing and how it chooses the path. What I'm seeing here might not actually be, oh, it is another ping. But anyway, once the request gets to router 1, it has a choice of either a gigabit line or an Ethernet line. So of course it's going to take the gigabit and then come down. And on the way back, it has choices of either fast Ethernet or fast Ethernet. So maybe it has to do with that. Anyway, hope that was helpful. I definitely feel better about OSPF as a result of going through that and then watching Jeremy do it. So I'll post this up, and then I think at some point this week I'll probably do another Python video and then probably several OSPF labs, just because it's an important concept for the CCNA. All right, everyone, have a good day. Thank you very much.